Always make sure you read the information given to you with these vector questions. Don't just assume that everything is done on the diagram, because it very often isn't. So PQ is the vector A, QR is the vector B, and it also tells you, crucially, that PS is 4QR. It also tells you that PS is parallel to QR. So if this is the vector QR, they tell you that PS is 4 times that. In other words, this vector here that takes us from P to S must be 4 times the vector B. So the first thing it asks you for is PS. Well, I've just done that. That's going to be 4B. Next thing, PR. Well, to go from P to R, let's go the long way round there. Let's just make that a bit thicker. So from P to R, I'm going to go from P to Q first, and then I'm going to go from Q to R. And remember, that means that I'm going to add the vector PQ and the vector QR. Well, PQ is the vector A, and QR is the vector B, so PR is just A plus B. And I like to write again which vector it is that I've just found, because I think it helps later. Okay, RS is what it wants you to find next. So to go from R to S, well, I'm going to go the long way round. I'm going to go from R back to P, and I realise that the easy way to do that is that I already know what PR is, so I'm going to go from R to P, so PR and RP are just the reverse of each other, and then I'm going to do PS. So if I'm going to go from R to P, well, I already know that PR is A plus B, so RP must be just the reverse of that, in other words, the minus version of A plus B. Let's worry about that in a minute. And then I'm going to add PS, which is 4B. So I'm going to do minus A, minus B, just removing the brackets there, plus 4B. In other words, minus A. And if I do minus B plus 4B, well, that's plus 3B. And I'm just going to write that again, because again, I think that's slightly easier if I know which vector it is I've just found. So RS, that's the vector I've just found, is equal to, and I'm going to write it the other way round, as 3B minus A. It's just a bit tidier. So it now tells me that the point T lies on PR, so that PT to TR is 4 to 1. Sometimes it helps to look at the diagram. So T lies on PR, so in other words, somewhere here. So there's my T, so that the ratio of PT to TR is 4 to 1. So I'm just going to write a 4 there and a 1 there. So the ratio of PT to TR is 4 to 1. And it then says, given that TS is K times QT, find the value of K. So it's a bit confusing, that. Okay, let's work out what TS is first. So from T to S, so that means going from T to R, I'm going to go TR plus RS, because I've already found RS here. It seems to make sense. So TS, I'm just going to see what happens. I'm going to go from T to R, and then I'm going to go from R to S. So let's have a look at TR to start with. Well, TR, I can see that TR is actually 1/5, because from T to R is 1 part, from P all the way to R is 5, so from T to R is 1/5 of PR. Okay, so TR, so I'm going to do 1/5 of PR, and I'm just going to write that again, plus the vector RS. Now, if I look at what I've already found, the vector PR, I found it up here, look, and PR is just A plus B. So I'm going to do 1/5 of A plus B, and then I'm going to add the vector RS, and RS was this one, that's 3B minus A. So let's keep going. I just extend the page there. Well, that's the same as 1/5 A plus 1/5 B plus 3B minus A. So let's tidy that up a bit. 1/5 A minus A. Well, if I do 1/5 take away 1, that's minus 4/5 A. and then I'm adding 3 and 1/5. Let's worry about that in a minute. 3 and 1/5 b. So that's the same as minus 4/5 a plus, and I'm just going to write that as a top-heavy fraction. 3 times 5 is 15, plus 1, well, that's 16/5 b. So let's just have a recap of where we are now. That's the vector TS. I'm going to tidy this up a little bit by factorising it. I can see that a fifth is a common factor, so I could write it as minus 4, so a fifth of minus 4a plus 16b. And I can also see that 4 is a common factor in there. So if I now take out 4/5, it becomes 4/5 times minus a plus 4b. And that's my vector TS. Okay, the other thing that I need to find now is the vector QT. So let's find QT. Let's go back up to the diagram to think how to do QT. Well, QT, to get from Q to T, I'm going to go from Q to P and then P to T. So I'm going to do QP plus PT. Right, the vector QP, well, I know that the vector PQ is A, so QP is just going to be minus A. And at the same time, PT, well, let's have a look at PT. So to get from P to T, well, that's 4/5 of PR. So let's just write that. So 4/5 PR. And let's keep going there. So it's minus A plus 4/5. And let's have a look at what PR was. Well, PR was there. It's A plus B. So it's 4/5 of A plus B. And if we remove the brackets there, so that's minus A plus 4/5 A plus 4/5 B. And if I do minus A plus 4/5 A, well, minus 1 plus 4/5, well, that's still minus 1/5 A plus 4/5 B. And that's the vector QT. Okay, if I now take out, I can see that 1/5 is a common factor here. So if I take out the 1/5, what I've now got is minus A plus 4B. And that's my vector QT. Okay, let's just compare the two vectors which I'm being asked to have a look at now. If we look at this vector here, the vector TS is 4/5 of minus A plus 4B. And at the same time, this vector down here, QT, is 1/5 of minus A plus 4B. And I can see that both of these vectors are multiples of minus A plus 4B. And in fact, this one, TS, is 4/5 of a vector. This one down here, QT, is only 1/5 of that vector. So I can see that TS is 4 times bigger. So I can now write that TS is actually just 4 times the vector QT, and that's the solution. Remember, the question said, given that TS is KQT, find the value of K. I can now see that K is equal to 4.